Hello everyone. Welcome to today's Industry Solutions webinar. My name is Lisa Stewart. 12D's Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll be running these webinars regularly again in the new year and recording them for posting on our YouTube channels with links through our website. Our previous webinars from this Industry Solutions series, as well as those from our training series and our 2021 What's Coming from 12D series, are available online if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll read out some of your questions to the presenter if there's time. Today's webinar about GVR will be presented by Sharleen Kolswamy of 12DNZ. The GVR is a comprehensive tool that enables rapid calculation, graphical display, analysis, and reporting for the averaging of GNSS vector observations. Sharleen will provide a detailed demonstration of the module and show how it can add value to your workflow. Over to you, Sharleen.
Thank you, Lisa, for the lovely introduction, and welcome everyone to the 12D Model GNSS Vector Reporting Module webinar, GVR for short. What is GVR? The GVR module in 12D is a function designed for surveyors to quickly and accurately reduce GNSS vectors and produce reports and QA and data. And of course, any final vectors from all the measurements you've done in the field for the purposes of Travis spreadsheets. Now, it is a module designed for cadastral surveyors, but it's not limited to that. So if you do GNSS surveys and you want an effective tool to reduce all the information from the field, can be for set out, control surveys, what have you, GVR module is for you. It's hardware agnostic, so it doesn't matter what color or brand you have in the office, whether you've got one or many. What you're going to get out at the other end is a report that is consistent throughout any project. It will look the same, and you can customize it to have your own logos and company information on the report. So it looks very sharp at the end as well. Doesn't matter what field procedures you have as well. GVR is not here to amend or edit your field procedures. We don't want to create extra work for you. The whole idea is the GVR module will just take your GNSS measurements from the field. We will run some analysis on it and then be able to produce vector reports, field notes, and QA information. GVR is a separate module. It is only available in 12D version 15, and your license does need to be under maintenance as well to be able to use it. If you have any queries or would like a quote, feel free to email us at support@12d.co.nz. And if you feel inspired after this webinar to check out some of our other webinars, please head to our 12D Model YouTube channel. We've got a data set here. This is a data set that is a real job. It's come from one of our clients. And this data set has been reduced just using the survey data reduction function. It's a Trimble data set, so what we've done is use the JXL raw file and converted that into a 12D field file and reduced it through the survey data reduction function. Let's go and have a look at that function just so we can show you some of the particularities that you need to be aware of. Grab that function there. So we've got a number of days of work there, and what we've done is just run a special map file against it. And this map file, if I just open that up, it's just a case of making sure what we're working with for the GVR function is just the data we need. So if we've got things like any marks that are not part of the RTK solution, if they've been keyed in or something like that, that's been taken out. So you'll see that we've got a whole bunch of stuff All the marks go into their own models. If anything with a survey method that is not RTK goes into a non-RTK model. Anything coded as a base goes into the base model, so it's very easy to identify which marks are your base stations. And then anything that is outside of marks just goes into a survey topo model. So if you've picked up fences, some occupation, etc., it is taken out of the cadastral tree and it's put under topo, just to make it nice and clear exactly what we want included in GVR. The other thing we do as part of this exercise in the SDR function is just make sure that we've got all our attributes being mapped to the string, and we also just explode point strings. Other than that, it's pretty normal, something you'd all be used to. Now, before we get into interrogating some of this data, I'd like to introduce you to the GVR toolbar. This is one up here. If I just undock that for a moment so you can all see, we've got the toolbar and the buttons are set up so that it follows on one from the other. The first one will help you set up your views. Down the bottom in the view area, you'll see I've got GVR view, GVR diagram view there as well, just to make your workflow a bit more efficient. The GVR view will be the one where we'll be doing all the work, and the diagram view is what we'll be using to do all our plotting. Following on from the view setup, we've got some project attributes and attribute manipulator file and so forth. I'm going to dock this toolbar back up again. The very last button, it's not part of the workflow, but it's something we've put there to make life a bit easier, is the attribute information. So if I open up the string attribute information, and let's go and have a look at what's actually in the data once it gets downloaded. So like I said, this is a Trimble data set. So we get a whole bunch of attributes coming in from Trimble. And we've got things like mark name, code, what sort of solution it is. So this is an RTK point, so it is going to be used in the solution. We've got a whole bunch of other information, quality control, how many satellites we use, how many epochs, what the horizontal and vertical precision is. So every manufacturer has their own way of setting out these attributes, which is great. But what we want to do is just put them in a format that is simplified and something that we can use for GVR. So there is a minimum set of attributes we need for each point for the purposes of performing the GVR function and creating reports. And as part of one of the processes for GVR, we are going to prep the data into a attribute format that we want to use. I'm going to go finish on that panel, and let's go and set some project attributes. What we're going to do now is, using the custom attributes panel here, is we're going to set some attributes with regard to our base and rover information for the project. You might set some project attributes when you start the project via the project details panel. And you may here identify project number, job title, and so forth. And you can use these as well in the report or in plotting. But what we're doing here using these custom attributes is, first of all, we can use this to assign our base stations, but also identify base station, serial number, make and model, and so forth. So if I go ahead and pick which one we want to use, now these files that you need to have in your library for GVR, majority of them are set up. This one is set up to a point where you just need to go ahead and edit it. So things like the map files are set up, these custom attribute files are set up and require a little bit of editing, and then any other files we use from now on have all been set up for you. So we've got a Trimble one set up, and I'm just going to go ahead and select that and go process. And all we're doing here is I'm going to go here and select my base station. If you've got multiple base stations, you can do that at this point. This is number one. We'll call it base number one, and I'm going to give it my initials for the surveyor name. And here is where you'd go ahead and select your base make, model and serial number, and same for the rover. Normally you'd have a pick list if you've got more than one set of gear, and you can edit this custom attribute file to reflect that. You can also make some of these fields non-editable. So if someone is coming and producing information using the GVR function, you can absolutely make it so they have to fill out every single thing before they can continue on from this panel. I'm going to go ahead and go process. I can also, if I choose to, create another base station using another mark, call it base ID number 2, base number 2, and I can go ahead and process that as well. And finish again. Now we've got some attributes on the base stations, and what we need to do next is go ahead and set up our minimum set of attributes that we need to run the GVR function. And that we're going to do using the apply attribute manipulator file. All this is going to do is go ahead and grab those attributes we've already downloaded from our data controller and put it on the vertex and in a specific format and name it simply, as you'll see. So I'm going to go ahead and use all the data in my survey data view. We've got attribute manipulator files already set up and they're in the library. So if I just walk right, we've got the various data collector brands. We've got 12D Field, Carlson, Leica, Magnet, and Trimble Link. So I'm going to go ahead and grab the Trimble one, and I'm just going to replace all the data and go apply. Finish. And now if I go ahead and look at the attributes again of one of the points, you will see if I go to vertex, you'll see there's a cadastral tree there now. And if I open that and go ahead and look at GNSS observation, we've got our minimum set of attributes. We've got a time and date stamp, number of satellites used in the solution, how many epochs, what the target height was, any comments. So if you've picked up in the field, you know, the mark is half a metre down or not found or something like that, all that information will come through in the comment. And then we've got our ID and code there as well, and our horizontal precision, vertical precision, and PDOT. This is all information you would expect to see in a QA report or a field note. So now we're ready to start creating our GVR function and processing some of this data. That's all the prep work that's required to get to that point, so nice and easy. If I just zoom into one of these points though, let's zoom in here and have a look at what we've got. We've got a whole bunch of measurements, and the first thing we're going to want to do is create an average coordinate. So again, a typical set of data set, you know, what's happened here is the surveyor's gone out on site and he's got into this ion tube here and measured a position at a given time, turned the pole around 180 and done another measurement. We're going to use all that information to create our function panel, and you'll see how we group those observations so it's easily identified. Okay, so let's go ahead and open up our GVR function panel. It's the fourth button, and if we click on that, that opens up our GNSS vector report panel. It's a function, so you can run and rerun it as many times as you like. If you get more data in, you can just run the function again with the additional information. So let's give this a name. We're going to call that GVR demo. And the first panel, first tab is the setup tab. This is where we go ahead and tell 12D which data we want to use and what projections and so forth. So I'm going to use everything that's in the survey data tab or survey data view. Projection for this project is going to be Mount Pleasant, and we've got a bunch of vertical datums and you can select which one is appropriate. I'm just going to select VD 2016 here. The display view, so this is the view that you're going to display the results in. The whole idea for me personally is once I've used the survey data, I'm done with it, so I'd like to leave the survey data view alone. I then work in the GVR view, and then after that work in the GVR diagram view. So we're going to go ahead and select GVR. And the next thing we're going to select is the point control model. Now, this can be a Travis spreadsheet model or any point control model, and it's going to go, GVR is going to go ahead and search within a certain tolerance, and if there are any points in your control model, it will grab it, use the mark name and the mark number, and also in our report, it can tell us any differences between a control model and the average coordinate of what we've measured, which is fantastic. The whole idea with the mark numbering and the mark naming is consistency between, especially your Travis spreadsheet information and your survey field information. So we do have a Travis spreadsheet in here, and I'm going to go ahead and select the points model here. If it can't find any corresponding points in your control model, you can give it a point start ID that it will identify for each of these points. So if, let's say, this iron tube wasn't in the Travis spreadsheet points, it'll start by giving these this point number 100, and then so forth the observation code. Now we've come to the next part, which is observation interval. This is the minimum time gap between observation grouping. So let's say a surveyor came and he set up his pole on this position here and took a measurement at 10 o'clock in the morning, turned the pole around and did another measurement. Now that's a group of measurements. So we're going to call that group A. Let's say he comes back and the amount of time you've identified here, which is 30 minutes. So he comes back at 10:31, takes another measurement and turns the pole around and another measurement again. That's your B group of measurements. So I think you can see where this is going. So we can see that there's a lot of measurements being done here. You can change that observation interval to suit you. We're going to use 30 minutes in this case. And the last thing you need to do in the setup panel is give it a point tolerance. So that's the search distance for finding the control points in your control model. So 0.1 is fine. And we're going to go ahead and click on set. That will set up our data ready to process. And we've got, so it's just said it's finished processing 125 points. What happens when you hit the set button is all your survey observations, so all this information you've got over here, they're copied to the observation points model in the GNSS, in the GVR tree. And there's some attributes identified to the points as well. And any base positions are copied to the base points model. If you hit the set button anytime from now on, what the GVR function is doing is actually going back to the original data source and looking for any changes. And if there are changes, it's going to grab the changes, put it in the appropriate GVR models, and then work from there. The whole idea is that the original data source does not get changed. So you've got that check and redundancy there. Alrighty, so we're ready to move on to our base vectors tab. So let's go to base vectors. And what we're going to do here is in this tab is as soon as we say populate vectors, GVR will go ahead and populate the vectors from any base stations that you've identified. So if I go ahead and zoom extents again, we've got two base stations, that Ramsey nail, reference nail there, and RN4. Because we've already identified our bases, we don't need to do them again, but the options are here. We can, first of all, you'd need to create a new base if you were to create one. So you'd go ahead and say, pick a point, give it a code, instrument height, and serial number. And then to come and assign the base to specific points or everything, you can come and assign the base here. So you can select from your list of bases. So we assigned our bases earlier on, base 1 and 2, and then you can go ahead and select how you want to assign those bases. You can do it by date or by one of these options here. Because we've already assigned our bases, I can go ahead and populate vectors, and it will by default, it will populate vectors from base number 1. Then you'd have to go to base number 2 and actually assign which points you wanted to create vectors to. Before we do that, we're just going to have a look at some of these settings. So any base vectors you create are going to go into this base radial vectors model. There's a color and a line style. If you wanted to round your vectors to the nearest second, you can. And then you've got some averaging options by coordinate or by angle and distance, up to you. We'll come back to this point on off button, but let's go ahead and populate vectors first. And it's added everything to our GVR view. So if we flip on over to the GVR view, we'll see that our vectors have been populated. Now let's go ahead, and it's been created from base 1. And so let's go ahead and have a look at one of these points, and you'll see that we've got just one vector to the average location. All of our other surveyed positions are around, but a vector to each position has not been created. So the vector panel has gone and grouped the observations, which we'll look at very shortly, and it has created an average location, and the base radial vector goes to that. Let's go and have a look at the attributes of these base vectors. And if we grab the attribute, string attribute panel, open that up, and just move that over. If we expand the attributes out, we've got GNSS base first. So this is all the base information that we've got on our vector. So everything we need for our base stations, serial number, make, model, etc., and the rover for that measurement, and we've got the base information and any projection information. Then if you look under GNSS observations, we've got C1, C2, and so forth. Now, your A vectors were the first group of vector positions surveyed. So that 10 o'clock in the morning, surveyor came and took 2 positions. Those are your A positions. And so we've got A1, A2, and this is all the information for that position. And then we've got the average. Okay, and then the surveyor came back 31 minutes later in our case, and we've got the B vectors and the average location. Now it's a bit, it's not that easy to identify in the format that's currently on the view. So I'm just going to go ahead and turn on some additional information here, some of our CAD models, and just get rid of the observation points model. Visually, that is fantastic. Just being able to see where these positions are, where the A's are and B's and C's are, you can immediately look and go, okay, the spread of these positions are fine. I'm happy with how that's worked out, happy with that all the points are being used in the solution, and you can move on. The other thing before we close the attributes panel down is we can open up the base actual vector information. So from all these positions, we've got average of your A and B shots and so forth. Then what's been done here is that a vector to that average A, B, C, and D position's been calculated, and then the GVR vector is the final average of all those vectors there. So what happens if we want to make some changes to the way the vectors are calculated? So if I move this panel out of the way, and let's go back here, you can see the location average and all the positions that have been measured in the field around it. And we've done a bullseye for you, so you can see the spread and where the how far from the location average each surveyed position is. And the cool thing about this is that you can have a look and go, well, there's some error here. There's potentially between the two C's, there's a bit of a pole error. So you can start removing some of these observations that you consider not to be good enough. It could be multipath, it could be pole error, it could be anything. So you can come in here and say, hey, look, not good enough. I'm going to take some of these positions out of the solution. And all you need to do is just go ahead and click on point on or off, go and select the positions you want to take away. Now just watch this location average here, and you'll see that it moves automatically as I start to move some points out of the solution. So I'm just going to pick and select this 1C observation and the B observation. And if I just refresh my screen, we've got the location average has moved, and all the positions in white are the ones in the solution, and anything that's red is turned off. If you then decide, hey, look, it's not that bad, I'm quite happy to just put them back into the solution, just go ahead and select point on or off and turn them back on again. Just like that, easy peasy. Now, for the purpose of the next part, I am going to turn some of these off just so we can see them in our report. And you'll see what they look like when we do the report. So at this point, we've processed our survey information and created some base vectors. And what we can do is we can actually just go ahead to our report tab. And in the report tab, we've got some attribute tables. The last one isn't available to us because we're not quite there yet, but we've got base stations and observations. If I go ahead and click on base stations, the attribute table pops up and I can say refresh. And this is all the base information, all the base stations that we've got, and this is some of the information that we've got on the base stations. I mean, I haven't put a hell of a lot of information in, but we've got base number 1 and 2, and the northern easting elevation, and the date that it was used. Go finish, and what we want to look at is the observations. So if I go ahead and click on observations and go refresh, these are all the observations that are in the survey currently. We've only got one base station, so the base ID is all 1. Use point is our first column, so that's, is the point on or off? 1 for on, 0 for off. So if you come down here, this is one of the positions that we turned off, hence the red. We've also got some observations that are in red. So we've got the delta northings and eastings from our location averages, and some of them are outside a tolerance that's been set in the background. Up to you what that is. I think in here it might be something like 12 mils. So we've got some of them are highlighted red, and the whole idea of this is you can come in and have a look and make a call on whether it's fine for what you're doing, or you want to turn some observations off. You can't do that currently, but from the improvement is coming, that if you want to turn an observation on from here, you can just right click and select and turn it off. That's an upcoming improvement. But one of the first things you might look at is epoch, and you can go have a look at the epochs list and decide whether you want to use them. But if you come to one that's only got something like 14 epochs, you can say, nah, not good enough, I'd like to turn that observation off, and so forth. So the attribute table is great just for having a wee look and making call on what you want. You can even look at the PDOP and the number of satellites. You might only have 3 or 4 satellites. For a solution, you can say, well, not good enough. We're in an age where we should be getting 20 or more. And so there's all that information that's going to get reported out is here. So you can have a look and make a call on whether that's going to be used in the final report or not. I can go ahead and finish on that panel. And in the report tab, we've got the reporting section here as well. We've got use TSS point names and show TSS difference. So if there are points in the control model that we selected earlier, you can say, hey, can you just go and grab the names from that control model? So you might go out on site and pick up any iron spike as OIS or whatever, and then when you come back in the office, you can actually name it using the name that's in your control model. The other thing is show TSS difference. So that's going to show the difference from the location average to the control model position. The report type, we're going to produce an HTML report and your report name. What sort of report are you producing? We're just going to produce a base vector report at this stage because we haven't quite done any of our final vectors. I'm going to go ahead and hit generate report. And that will be opening up shortly. It's opened up on the other screen. I'll just pull it across. Here we've got a base vector report, and as I mentioned, this information has come from our project attributes. You can put your own company logo and company information on it, so in the end it looks pretty sharp. And as I said earlier, the whole idea is that you have a consistency in the end product. Doesn't matter who's doing the survey, what the project is, or how it's been done on the field. What comes out is a consistent product that you can use for QA, for handing in as your field notes for LINs, and so forth. We've got our base station information here, and then following that, this is our base vector report. So first column is it using the solution? Yes or no. The base that the observation is coming from. The code, now this has been grabbed from your Travis spreadsheet, and the unique ID as well, the point number. We've got all our measurements, and then we've got the epochs, the precisions, the PDOT, and so forth, and a time and date stamp. And then we've got the location average. Following on, if we scroll down, here we go. This RN9 was where I turned a couple of observations off, and as you'll see, it is 2 turned off, and they are N for no, they're not in the solution, and they are grayed out. So for anyone QAing this, they're not sort of having to go into 12D and interrogate the data to be able to find out what someone's done. The report is very transparent. It'll tell you, exactly what's in the solution and what's been taken out. So someone might look at this highlighted observation here and say, well, actually, you've got 15 epochs, so many satellites, and that's the deltas. You know what? I'm happy with it. Go and put that back in the solution. And then all you need to do is go back to your vector panel, point on, and you're away. If I scroll down now, just while I'm doing that, all of these location averages are to 3 decimal places, and in the panel we had the option of showing the bearing to the nearest second, so you could do that. The reason it is so is because these are your raw vectors, and that's what the display accuracy, or that's the accuracy it's been calculated to. When we come to do our final vectors, that's where you have some choices in terms of the rounding, etc. So I'll just keep scrolling down. We've got our coordinate report here. So these are all the points in our Travis spreadsheet, the unique IDs, our Travis spreadsheet, our coordinates, and then with the differences between what's in the Travis spreadsheet or your control model and what the location averages are. So again, immediately you can have a look and say, all right, yay or nay, and move on. And then we've got our comments, that these are marked descriptions that we've got come in using our attributes. So we've had a look at the points in the distribution around the location average. We've had a look at the report. Another way to, if I move that panel out of the way, another way to have a look at the vectors and do a bit of QA would be to just label them. Label the final vectors and have a look at any differences and things like that there. Just going to, nope, that's all good. I'm going to go ahead and label those attributes. So the vector, the GVR vector, bearing and distance, any differences and so forth are all attributes. So I'm just going to go ahead and use our labeling tool here. So the string attribute and property label, just move that out of the way. What we're going to label are the base vectors, so the actual final radiation vectors themselves, and we have set up all these attribute files for you. So if you go into the library, we've got the base radiation labels. I'm going to add it to the GVR view, and all I need to do here is just hit create and update. If I go ahead and just change the scale so we can actually see some of these. It's probably not a great one because there's only one position on that. Go here and we've got the average vector, and that's the largest difference, and then we've identified that largest angle at the distance difference there as well. So you can have a look and say, hey look, 7 mils in 4 seconds, I'm quite happy with that. Or you can have a look at one of these ones here. Sorry, zoom that in properly. You can see we've got 33 mils spread between the points, and then you can go to the vertex and have a look at the spread of your A's and B's and C vectors and make some calls whether you want to use all of them or not. So pretty easy, quick way to label, and these label files are all set up for you. It's a quick and easy way to label these things and go and interrogate the data and make some decisions. Now, if I bring my GVR vector panel back, we've got, so we've done the report, had a look at your base vectors. So next up is final vectors. Okay, so final vectors, this is ultimately what we're going to trace into our Travis spreadsheets and show on our plans. All you need to do is tell 12D where you want your final vectors to be drawn in between and go ahead and attribute those vectors. And if, let's say, these radial vectors from your base station are what you want to be your final vectors, you can just easily copy all these vectors into this model here, the final vector model, and then just go ahead and attribute the vectors. But what we're going to do is we're going to create some final vectors between some of our measured points, and just make sure in your CAD properties toolbar you've got the correct model name, and then you can just go ahead and create those lines. I will go ahead and create some lines that I want in my final vectors. I'm not too worried about where I'm snapping to, because I will demonstrate that you don't really need to do that. 12D will go ahead and snap to the correct points as necessary. We'll just create a few more of these, and then we'll go ahead and have a look at what our final vectors look like. Okay, that'll do us for now. Below where we told GVR what final vectors to use, we've also got a plan vector model. Now, you may have some adoptions in your Travis spreadsheet that you want to compare these against, and easy peasy, all you need to do is actually go and select that vector model. This can be a control model with vectors in it already that you want to compare. In our case, we do have some adoptions, so I'm just going to go ahead and select adoption. Below that, these are just CAD properties for the lines that we've drawn. When we attribute the vectors, they will change to a green color, which is already green, that's fine, but a dashed line style. Now, before I hit attribute vectors, I'm just going to zoom into this point here so you can see that I wasn't very clever when I was creating my final vector lines, but it doesn't matter. I'm ready to hit attribute vectors, and if I just do that now, it's done the 5 lines that I created and attributed them, and if you see, I have it has snapped to the location average. I'm just going to hit set. What we can do now is go ahead and look at the attributes of these lines, and if I go to the attribute table, grab that up and open these up here. So this vector here, I know I've got an adoption in my Travis spreadsheet, so hence why you'll see we've got our GVR vector, a rounded GVR vector, and then a final vector. So this is our final vector that's been calculated, but hang on, we've actually got something in our Travis spreadsheet as well. So it's actually identified a plan vector, and it's saying, hey, look, there's one in the Travis spreadsheet, and this is the bearing and distance for it. So you can come in and very quickly say, hey, there is an underlying plan vector, and just do a quick comparison. In the attributes, in the plan vector attribute, you'll actually see the bearing and distance difference between the two lines, between the final vector and the Travis spreadsheet vector is identified. So one way to look at these will be just to have a look at the attributes like we are. Another way is we can go ahead and label them like we labeled our base vectors earlier. So if I just go ahead and label these Travis spreadsheet final vectors, there is a label file already created. So vector labels, add them to the GVR view and go create an update, finish, change its scale, just so I can, oh, that's a bit big, go finish, and if I zoom in, sorry, there we go, we've got, that's the average vector and the differences. Selection, so at the moment we haven't said, hey, you know, if there's a planned vector, please use that. We do have that ability, which I'll show you very shortly. But it'll also, so that's your GVR vector. And then it's also saying, hey, look, I've got a plane vector I've picked up. That's the plane reference, that's the vector, and then we've got the differences shown here. Again, anyone QAing this can, or anyone processing this can very quickly have a look and say, yep, actually I'm quite happy with that. I'm very happy with my survey. I don't need to go and adjust anything. What I'm going to do is just make sure that that final vector is the same as the underlying vector and be done with it. So what we can do is if we go to the report tab and we go to final vectors, you go refresh, and I'm just going to make this panel a wee bit bigger. So we've got, and I'll make that a wee bit bigger. So we've got a few vectors that are in the Travis spreadsheet as already. We've got our GVR bearing and distance. We've got the plan bearing and distance that's been picked up, and then we've got the plane reference and the differences between the two, between the GVR and the plane bearings and distances. You can have a look and say, hey, you know, those differences are absolutely fine. What I want the final vector to be attributed with, so when you trace it into the Travis spreadsheet, you get exactly what you're after, whether it's GVR or the underlying plan vector, you can actually go and make a selection. By default, if there's nothing in the selection column, it will take the GVR final vector. But if you decide, hey, look, you know, a line between 168 and 169, I'd like to use the underlying plan vector, you can simply right click and select plan. We can do it for all of these. We can right click and select plan. So the underlying plan vector will become our final vector, and we can type a note in saying fine. Or something like that. And I can just hit update. So it saves those attributes away. I'm going to go ahead and hit update, and it'll say attributes updated. Go finish. Go back to the final vectors tab and just go set and attribute vectors. And if we zoom in and look at the labels for those vectors, and I'll just quickly relabel it because we have just amended the attributes. We've selected our underlying Travis spreadsheet vectors, use the correct label file, GVR view, and go create update. And because the string and property label attributes are a smart drafting option, you'll see that immediately it's updated the current labels, and because we selected plan in our final vector attribute table, we now have the selection as TSS, that's the DP reference. Then we've got what's underlying and the differences as normal. And if I go ahead and look at the attributes for that particular vector as well, it is reflected in that too. If we go ahead and open the cadastral tab, and there's a plane vector, and if I go and look at the final vector, it'll say it's a TSS vector, and that's what it's grabbed from the Travis spreadsheet, and there's the bearing and distance references. I can go finish, and just while we are looking at those selections, I can open up the Travis spreadsheet and just show you that when you do trace it, it will bring through. So if I get rid of those models, okay, and that's the line I want to select. If I go ahead and around that point, this is just a demonstration, so I'm not worried about the point numbers. And if I trace the vector through, you'll see that we've got our vector coming through as per what was in the underlying control model. We've got the bearing and distance references, and the type comes through as adoption, you can change that to GPS if you like and go from there. Or if you want to keep that as an adopted vector, all the same. But as you can see, the bearing and distance references do come through. Okay, next up, we'll go ahead and have a look at the report. So if we go ahead and just make sure we turn on the final vector report in our HTML and just hit generate report, and that'll go and do its thing. And bring it over from the other screen. Okay, so nothing's changed at the top. We've still got our base vector report as it was. All that's been added is we've got a final vector report. We've got from name and ID and to name and ID. We've got the calculated vectors from GVR, and we've got any plan vectors that have been picked up. So you get that comes through in the report as well. And then you've got your final vector and any notes. There is an improvement coming in where we will show those differences we saw earlier in this table as well. So that's another handy thing that's going to come through. But yeah, you know, it's pretty transparent what you've selected, what you've done, and if you decide, hey, the differences are too much, you can use the final vector can be your GVR vector, and you can explain that in your notes. So it's again for someone who's QAing it, they can actually see what you've done fairly clearly, and that really helps for anyone doing any QA. So if I close that report out, that's pretty much it with the GVR panel. We're just going to have a quick look at plotting next, but also if we look at parameters, we can, in the parameters tab is this rounding information here. So with your final vectors, you've got some control over the rounding. You can put in, you know, how many, the decimal places, so you might want 2 dp here for the rounding. You can also say what the rounding that you want to be for specific distances. You don't have that ability for your raw base vectors, but for your final vectors, those are there, and that's all on the parameters tab. That's really it for the GVR panel. I'm just going to go ahead and click on set and finish. And let's go to the GVR diagram view, because it's all well and good. We've processed everything, but what I want to do is I actually want to be able to plot this out and give it to a surveyor to look at. And I can go ahead and label, just quickly label the mark names as well. And there's a specific label file for that, and add it to the GVR diagram view in this case, and go finish. Make sure the scale is at 1:1. And what we're going to do is just plot this out for the surveyor. Now, easiest way to do that is using multi-page plots. So plot, multi-page plots, and create. And there is a GVR master set up in the library, and I'm just going to go read. Just wait for that to pop up. It's always fun doing it on a single screen. And it's just refreshing away there. These frames on the left-hand side and the right-hand side. So we've got a central frame in the middle, and then we've got our specific mark frames. You know, took a few minutes to set up. And as per normal, if I move that to the side, you'll need to do some jiggery pokery with the marks and labels. But being able to give this to someone as part of the QA, amazing. They can have a look, especially at this point here, and see, okay, you've got a bit of a spread, and then you've got 2 marks that are red, so they've been turned off from the solution. And they can make a call on whether that's, you know, the signing surveyor can make a call whether that's what they want or not. We've got some vector labels here for our final vectors and our base vectors as well. Again, they can do a bit of QA on that. Quite good for vector diagrams if you're getting differences between underlying surveys, or if you're in Christchurch, if you've got some earthquake movement and that sort of thing. So it's a pretty powerful thing being able to do a plot like that. And with multi-page plots in 12D, which is part of your base module, as long as you're under maintenance, you've got it. You can use that anytime. Just set up a plot file when you start the project and just keep hitting plot over and over again. So there we have it. That is GVR. From woe to go. Again, there's no changes required to your field procedures or anything like that. It's just it's a tool that's going to help you quickly and accurately process GNSS vectors to then create your final information, so your final vectors and QA information for the purposes of lodging a survey or even internal QA. Just a couple of things before we move on to the Q&A part of this webinar. So GVR is a separate module and your current license needs to be under maintenance to add the GVR module to it. It is only available in version 15. And if you've got any questions, please feel free to contact us at support. And as I said earlier, there's plenty of resources on our YouTube channel as well. So if you want to know any more about plotting that we saw today, there's plenty of information on our YouTube channel. Okay, that's all I have today. So back to you, Lisa, for Q&A.
Thanks, Sharleen. Now, I think must have been very comprehensive because the questions that I've had through have been mostly on a bit of a theme, actually. So a couple of people have asked, what are the requirements in 12D model for me to have the GVR module?
Good question. So requirements are you need to have version 15, CU1K and above, and your license needs to be under maintenance. And if you're wanting to trace things into Trimmer spreadsheet and stuff, you will need to have survey. And if you're a Kiwi, you need the LINS XML module as well, just to make the whole comprehensive thing work. But as a minimum, license needs to be under maintenance, and it's version 15.
Thanks for that. And the other question that keeps coming through is how much does this package cost, or how much does this module cost?
So the module is 2,400 Kiwi XGIST, and it's per license.
Great. Okay. And yeah, and people can talk to their local sales team as well, I'm sure. So the recording of today's webinar will be available in coming days through the webinars page on our website and our 12D Model YouTube channels. And I think we're going to put some Vimeo links up as well. So keep an eye on our emails and social media for details of future webinars. And don't forget, our tech forum is back to being an in-person event next year in Brisbane. So hope everyone's already grabbed their tickets for that. We do still have some places left. That'll be in July next year. If you need to contact us in the meantime, our details are on the screen now. And if you have any further questions, feel free to send them through and we'll get Sharleen to answer those after the presentation. Thank you very much, everyone, for attending. That concludes our presentation for today, and we hope to see you at future webinars.